Thank you so much for joining this channel. So we are actually already started this KYC AI agent for long back. I think those who haven't visited, please visit. Those who already visited, for them, this is the almost you can say the last one. It is like an end-to-end KYC agent. The concepts and everything already discussed in the previous sessions. So let's see what is waiting for you in this session. So you can see it is a KYC agent platform, production style, fully production style that we are doing. So before going to the detail about this session, let me reiterate or recap what we have done so far. Those who haven't visited, part 1 to 5, we already did the core AI. What is, first of all, what is KYC? What is KYC AI agents? How API works? How to do the orchestration? Everything has been described in the part 1 to 5. Please visit that. Part 6 to 8, we have used Docker, Kafka, event-driven workflow, retries, DLQ. So it's not only an AI agent, but those who are in the .NET arena, those who like DevOps, deployment, event-driven architecture, want to know about asynchronous communication. So those also been introduced while developing this KYC agent. So please go through that. This will help you to build up your knowledge to do some other AI agents or normal .NET work also. And but for 9 to 11, it is dynamic routing, approval workflow. As I said, right, in the earlier sessions, we have an automatic approval and as well as human approval when the risk is very high. So this concept of resume, consumer memory, and observability has been introduced. Observability, definitely, it is for logging purpose. And the final one that we will show today, that is React frontend. We have implemented or used a React as a frontend where you actually can visualize what we have done so far using the API Swagger part 1 to 11. But in the final round, we are using the front end so that you can visualize what exactly we are sending the request, how we are submitting, how it is getting approved. If it is not approved, then how it is pending approval, then pending approval to in progress again into the approved state. So the life cycle of the various status of the KYC agent will be discussed. And the backend will be same what we have discussed in the human workflow. So what is KYC architecture concept? So it is now we already moved to the event-driven architecture. We have introduced the human in loop AI also, workflow orchestration, dynamic runtime execution, rack style memory. Even though the memory has not been used in full capacity, but yes, there is a memory also. Idempotent processing to avoid duplicity, retry and resilience in case any failure comes. Again, it will try 3 times and also use the resiliation. And if it is fails, then it will gracefully go for this DLQ. Everything has been discussed between part 1 to part 10. And different is the microservice communication. We have these are different services. So what are the components we are using in the last one? React frontend, API layer that you already done in the part 1 to part 10. Kafka is already there for asynchronous communication, decoupling between producer and subscriber. Supervisor agent who will actually monitor how agent will perform with the child agents. In a orderly fashion. Runtime will decide which one to pick up based on the conditions given by the user. Here in agent runtime, the decision will be given by the LLM. Here we are using LLM as a cloud foundry. We will show that registry is nothing but how many agents are there. In our case, we have a risk agent. We have other agents also. Will show into the demo. So multiple agents are there, and memory layer for the storing that or remembering things. So this is the architecture. You can see the React frontend. Customer will enter the KYC details, submit the request. That is the first step. Then view processing status and human approval if required. When the risk is high or something, then the human will come up. And what is in the API layer? We have a KYC controller which will actually receive the details when user submit that. That will be taken care of. Approval is in case something is pending approval, that will be approved by the approval controller. And also the status, since we are doing the KYC agent, there are multiple statuses, like first time it is submitted, then processing, it may be pending approval, and then again recompleted, right? So all the statuses will be managed from the API end. So this is one done. Then the Apache Kafka will come. Kafka will actually have these topics. Whatever we're discussing, the same thing we'll see in the demo also. So we have a 2 topic KYC request where actually user submit the request, and if approval required, then the topic KYC approval events will pick up that for the submission. And then we have to Kafka consumer and resume consumer. Kafka consumer already mentioned, that is for processing the data received from the user, and resume customer is if there is a pending approval required, and any senior or any person who is authorized has given an approval, then the data will be sent to the KYC approval events, and that will be picked up by the resume consumer. Resume consumer will pick up where it is left off and complete the remaining process in case of human interference. Otherwise, it will be automatic approval. Supervisor, the task is supervisor, managing as an orchestrator, which will do the routing decision. There are so many, that agents are there, but based on the user request, it will pick up the right agents. If there are multiple agents, right, risk agent or identity agent, so it will pick up based on that. And that decision will be taken by the LLM and given to the routing decision. Risk evaluation and everything will be done. So supervisor will do all this workflow and everything. And finally, this agent runtime will do the execution. Agent registry, it is nothing but the collection of this fraud agent, risk agent, identity agent, and memory is only for holding the value, reliable and status. So this is overall we have API and the front end React. So what is the flow actually? So user will come to the front end, submit the KYC, Then the moment you will submit the KYC in the backend, the KYC controller will be called. The message will be serialized and drop into the KYC request. So whatever you mentioned in the topic, the same name you will see in the demo. And once the data has been pushed into this topic, the Kafka consumer is the Windows service which will polling this KYC request. Will pick up the data, and then the supervisor agent will given to the supervisor agent. Supervisor agent will talk to the router agent, router decision, agent runtime, whatever agents you want, and all these things will be done once the risk evaluation done. So there are two cases: low risk, high risk. If it is low risk, definitely it will be go to the completed state. But in case the risk is high, here we have taken more than 70 as a high risk. At that case, it will go to the pending approval, and that will go to the topic, that Kafka topic approval events. Then human approval in UI, human can see that there is approval required for someone senior. Once this human give a approval, then the data will go to this approval events, and resume consumer will pick up the data which is already being approved by the human, and we will do the same thing what has been done like in the low risk case, supervisor agent, and status the completed. So only this is the difference between high risk and low risk. The pending approval status will come in case of high risk, and for low risk there is no pending approval, it is directly approved. So this flow you have to remember. This is the entire end-to-end architecture, how it works. User React, what is the role of API layer. You can see whatever we discussed in the previous two slides, the same thing, but in a diagrammatic format for better understanding purpose. Publishes events, Apache Kafka, consumer is there, so the agent will be picked up, LLM will route, agent runtime, agent registry, memory status. So everything has been discussed. So you can visit that diagram, and you can study it, what exactly, how many topics we are using, how many Windows service we have, Kafka consumer, as well as we have resume consumer. Okay, both will be take part in both the cases, low risk and high risk. But in high risk, resume consumer will come up, and Kafka consumer both. But in low risk, only the Kafka consumer. Resume consumer is not required. So please visit that. So business flow, the same thing what we discussed. Customer submit the KYC, the request will come, invoke supervisor agent. So this is the all over flow that we already discussed. Low risk, we will that this is the demo thing that we will show you. The user will submit, API will receive, Kafka message will be published. Simply risk is low, and it will be status completed. So that you can see in the diagram also. This is the for the high risk, only the pending approval is the additional thing, because the human is involved. Sequence diagram, user React API topic, so that how these things happen. So you can see the same thing what we discussed. Submit KYC, API layer will talk to the Kafka. Kafka will actually being called by the consumer. Then consumer will actually initiate the supervisor call. Agent runtime and store, everything will be happen. Then at the the supervisor will check whether it is a low risk or high risk. If it is a low risk, it will go to the complete, but it is a high risk, then it will go for the approval process, KYC approval events. Then the approver will approve, publish, approve, and that consumer approval event, resume workflow, and the re-execute and update the status completed. So this is the, and the get status will give you the time to time statuses from the API to UI. So this is the flow of our high risk and low risk. This is the solution that we discussed in the part 1 to part 10. Same thing, there is no difference, only additional parties. Earlier we are doing through the Swagger from the API. Now we are using the React as a front end. Human workflow, we discussed that we are using the pending approval in case that is score is more than 70. And front end also polling that API, because the statuses will come from the backend. So the front end React will do the polling of the statuses, so that user can see the right status at the right time. It will not wait for forward to process. Whatever server will give you the latest one, that will be shown. Approval panel will be there. Approval controller, resume controller, all will be shown. This is DLQ already discussed in the previous, that this we will not show. It has already been shown in the last videos. Here you will only focus on the low risk and high risk, and how these two are working with the statuses. So final demo, we will do normal KYC and then higher risk KYC, and we will show you the Kafka events in the Docker, that you already shown how to use Docker for running this, the application API, showing the consumer processing logs, approval, resume, and completed. This is a future one. Maybe we will enhance in future, but I am thinking to move to the another agent, not the KYC. KYC we have done many things, but yes, if you want, you can also try from your end how to implement Signal R for real-time communication, database persistence properly. Now we are using dictionary also, authentication, authorization, production deployment to Azure, okay, and vector DB backend as a memory or RAG. So I will try if I can do that. Otherwise, you also can try. So we are done with this PPT. Let's go to the demo to understand the low risk and high. So what is the new things we have done? We have added this front end project. Front end have this, the components, KYC for submitting the request, submit KYC, and approval panel when human intervention is required, when we give the approval. These are the API call being made, submit KYC the first time, then approval KYC when the human is required. For low risk, this is not required. Low risk only submit KYC and the KYC status. So status we are handling from the backend, because that will give you the right data, like it is in a submission, so submitted, or it may be in progress or pending approval or completed. So let's run this. Okay. So for that, the first work is we have to start this Docker, because our application is deployed in the Docker. So what we will do for the Docker? So we'll go to the command prompt. How we'll go that? We'll take the path, Node.js command prompt. So into the path. Now coming to the first command, we have to start the Docker. So container has started. You can see the container has been started. Now we'll go inside the container to create the queues, right? The first queue is for submitting the request. So how we'll do that? So first request is KYC request. You can see the topic has been created where user first submit that request. And how to listen to the queue? We have to start this listening. Now we need one more terminal. So that is not required right now because first we will check the LORIX. So in the LORIX, there is no pending approval. It is simply submitted, then in progress, and then it will be completed. So now we have to start the React. Okay, and before that, we will start this application API. So what we will do? Since we have done all in a single solution, we have to switch it because consumers are Windows services. So for our consumer, so let me start this. One minute, I think. Let me check. Kafka consumer, Kafka producer. Kafka consumer is already declared over here. So we have subscriber topic not available events. Okay, subscriber topic is also required. So what we'll do? Let me create that topic also. So for that, we will already open. Okay, not this one. Anyway, we require it when the highest will do. The Docker is already running, only the terminal is there, so no need to create a container. So now let's see KYC approval events, right? So for that, now events, we can do one thing. Okay, let me open that another also. Because anyway, we require it. We'll go inside the machine. So now all the required topic has been created. So let's see. Also, you can see that topic of everything has been created. Let me check. So as we discussed, we have two one, and the third one is the status. So let's run the your UI. So we have front end. So what we will do? and we'll use npm start. So you can see that the first time we are using a front end using the React, which we discussed till part 10 or day 10 using the Swagger. So now the same Swagger will be called from the agent. So as I discussed, we will check the first, the low risk. So it is a low risk. Let me open this in the this browser. So we'll check the data has been submitted or not. So let's see. How it is saying submitted. We have to go over there and check the KYC. See that the KYC request, as we discussed in the PPT, the data has been received. Right. Now we have to check this data has been approved or not by the consumer. So for that, what we need to do, we'll stop it and run the consumer. How we'll run the consumer? Kafka. So there is a Windows service, right? Because Windows service will listen to the KYC request topic. So why it will go? It will go to the SRC Kafka consumer. See, now it has came. See the data. Same data which has been submitted by the user. Now it will check whether it has the risk and other agents. So what are the agents we have? We have this number of agents: fraud, identity, KYC. All are registered under the KYC agent registry, and supervisor will take care of this. And the router agent will take the decision using the LLM. How we'll do that? Let's show that. This idempotent check is the first time. DLQ and everything we have to discuss. Assuming in one shot it will happen. No retry is required. Now supervisor. Here the LLM will start working with the, because you know that based on this data, we have this all of the agents. So what are the agents actually required? It may happen all agents required, or maybe some of them based on the situation or the input criteria. Now it will take the data or take the decision from the LLM. Here we have the semantic kernel. So semantic kernel has given the data and said all we need to check. The decision has came. Now we'll check, as I said, we'll check the risk score. Based on that, we'll decide whether it is a low risk or high risk. So it is low risk 30. What about the status? Still submitted. So now it will go approved. Since it is not pending approval because already risk score is low, so directly it will update. You can see submitted. This is the status, right? Which will give you the status that is being pulled by this React. So if I remove the debug, then you will see actual flavor. Disable. This is the status. Now see completed. So this is the way you can discuss or understand this low risk case where there is no human is required. Now we'll go to the second step. So what we'll do for that? We'll stop it. Again, we have to drop the data. Go to the program.cs. Stop this hosted service and start this. Now we will put this data. So we have used the fail keyword just to show off that it required a pending approval. When the fail is there, and the score will be like more than 70, something like that. We can refresh it also. So we are taking a new case. It is submitted. How you can see that? You can see that John fail pen has been submitted. Now again we'll run the Kafka consumer. Kafka consumer will check the data has any failing case or risk is high. Then it will send for pending approval. So again the same thing. Kafka consumer will open hosted service, and this is stop. Here you can see the changes because I have stopped the debugging. See, the moment I send the fail one, the status has came pending approval, and that is coming from the backend, not from the front end in hard coded, right? So manual approval is required for this KYC John fail, and someone senior will get an email or something like that, and he will click on the approve. The moment it will click on the approve, what will happen? We'll see. Where we'll see, we have two data that you already received. You can see here is the pending approval. Approval request already been came, that for which we have to give it, because still it is approval is false, but the moment you click on the approve, it will be his approval will be true, and then the resume then the resume consumer will be activated. So what we'll do, we'll click over here. So now it will not so now we have to stop it again because we are doing the same solution. We have to call the API, so we need to run it as an API, not as a Windows service. So we are switching. One time we are using as a producer controller, and then another time we are using as a Windows service. So now it will click on this, where it will go. So there is one code approval. So it will come over here, right? And it will drop the message to the producer. We will show that. Now click, see now already being called. And why it got to the data? KYC approval events. How we'll check that? KYC approval events. Now that this data is true because it is humanly already given an approval. Now what we will do? We'll run the resume consumer. How we'll run the resume consumer? Resume consumer is because the approval has came, right? For that, we have to on the resume consumer as a hosted service for that, and stop it as a API. The moment I will run it, we'll see the status over here also. See, this status updated. How it gone? The data being picked up from here, and where it gone? So if you go to the resume consumer, it will read the data from the approval events. Is approval equal to true? So once everything has been done, it will call again the supervisor agent that we discussed in the diagram. Then it will come here. The risk score is already we discussed, right? And this will not go inside because it is already approved. Mark. So first time when this Kafka consumer has been called, it was false. The risk score is high, and it goes to the pending approval status that we have already seen. But once it is approved by the human, and then the Kafka resume consumer being picked up the data from the this approval request or approval events, and it will skip this code and status updated. This is the high risk case. So I hope you understand these things. So if I see that code, let's I'm giving a small example. We already discussed in other videos. We have these agents, multiple. We are just bifurcated these two cases based on the risk agent. 30 means okay, more than 70 is wrong. This is for the human to approve. This is for submitting the request. This Kafka consumer actually process the data based on the receipt input by the KYC controller. But in case any pending approval is there and require human assistance, then approval controller will be called, followed by the resume consumer, which will pick up the data from the KYC approval events and mark it. So there are three queues: KYC request, KYC. This is KYC request. This is KYC approval request. And once user given submission that approved, then it will go to the QA approval events. So these three queues are there, and that you already discussed into this diagram. Please look into this when you try to understand how it works, and also we check this flow. exactly how it works. Then you understand that how an agent can use or leverage the existing .NET or the cloud feature. Also, message broker, asynchronous communication, agents, agent runtime, storing status, human approval, without human approval, auto approve, all the processes I have tried to discuss. Please go through that. If you need the code base, please let me know in the comment section. I will zip it and I will DM you directly into your email ID. Thank you so much. We will again meet into the for a new agent. Uh, and in future, we will upgrade the KYC.